Good morning dear students, welcome back. ನಾನು ನಿಮ್ಮ physics professor Dr. Nagaraj ಅಂತ. So already I have uploaded a few videos on module 1, that is on quantum mechanics and modern physics, and it is especially for triple E stream: electrical, electronics, instrumentation, telecommunication and other allied branches. So I am discussing only questions and answers, and the detailed notes will be shared later on, and question and answers links are given in the description box. Please go through it. Come, let us start with the third module, which is about lasers and optical fibers. The syllabus goes like this. We have two parts here: lasers. In laser, characteristics of laser, Einstein's theory, that is expression for energy density, construction and working of carbon dioxide laser, and two applications: laser range finder and laser printer. And of course we have another part, that is optical fiber, fundamentals, that is total internal reflection, and basic definitions like angle of acceptance, numerical aperture, fractional index change, etc., modes of propagation, V number, types of optical fibers, and then attenuation, that is loss of energy in optical fiber, and then applications, point to point communication and optical fiber sensor. Well, this syllabus is available in even VT website also. Please go through it. Come, we will start with the question number 1. First I start with lasers only. Look at this question. Expand the term laser. What are the properties of laser? See, laser actually it is nothing but highly intense beam. It was designed, the concept of laser was given by Einstein way back in 1917, but nobody took it so seriously because of so many other major factors like radioactivity and other things, and also because of those two world wars, World War I and World War II. Scientists didn't give much attention to laser. Only after the Second World War, laser came into limelight. In 1953, C.H. Townes designed what is called maser, and in 1960, T.H. Myman designed what is called ruby laser. Okay, and the laser stands for light amplification by stimulated emission of radiation. You have to focus on two words here. One is amplification, another one is stimulation. Amplification means enhancing the strength, increasing the number of photons, and stimulated emission means emission of the photons at a time from the particular energy level. When de-excitation takes place from a particular energy level without anybody's support, then it is called stimulated emission. See, what is actually stimulated emission? I will explain. See, normally what happens when you excite atoms to higher level, say this is ground state, this is higher state, atoms will be in the ground state. By giving some extra energy, you excite it to higher level. So when it goes to higher level, it stays there for 10 power minus 8 seconds, and then it will come back. While coming back, it will give the energy in the form of photon. This will happen obviously and naturally. This is called spontaneous emission. Suppose before 10 power minus 8 seconds, if you force the atom to come down, if you instigate the atom to come down, if you influence the atom to come down, or if you stimulate the atom to come down, then we will get more number of identical photons. Suppose if there are 2 atoms or 3 atoms or 4 atoms or 5 atoms in the higher level, if you influence all of them to come down, they all will jump to the ground level at a time, so that we will get laser light like this. See, ordinary light will be having all possible wavelengths like this. Monochromatic will be having same size but different phase. Look at the diagram. Whereas laser, not only same size, the starting point is also same like this. I hope you are following the diagram. So here, crest, trough, they all are matching, so that they are in phase. So laser is therefore highly monochromatic beam, highly intense beam, and highly coherent beam, and well polarized beam. So these are all the characteristics of laser, and this is possible only through stimulated emission. We will learn more about the concept of stimulated emission in the subsequent questions. Well, here comes the properties. Look at the first property. Light is nearly monochromatic, maximum monochromaticity. Monochromaticity andre ಏನು ಹೇಳಿ ನೋಡೋಣ? Single wavelength. So it is monochromatic. Next, it is highly coherent. Coherent means the starting point is same, so that the path difference or phase difference is maintained constant. Whatever the difference exists here, same exists even here also, next also, like that. And laser beam is well collimated. It can travel in a narrow beam. You believe it or not, it can travel several thousands of kilometers with minimum deviation. Ordinary light cannot do that. And then energy density is extremely high. The laser beam is so strong that you can drill holes in the diamond, you can cut metals, you can weld metals, okay, and you can reach the temperature up to 10 power 30 Kelvin. Such a high temperature we can achieve. And of course they are well polarized. Laser is well polarized beam. So these are all the properties. But normally this question will appear along with some numerical problem, something like that, because this is not a question for 8 marks or 10 marks, maximum 5 marks. Definition of laser 1 mark, property 4 mark, like that. Okay. Now comes one of the major question in this chapter. I told you Einstein gave the concept of laser, so he only gave the theory. What is the theory name? Give the theory of Einstein's A and B coefficients, discuss the conclusions, or obtain the expression for energy density of radiation using Einstein's A and B coefficient theory. Arrive at the general form of the expression after comparing with Planck's equation. ನೋಡಿ ಎರಡು ಕ್ವೆಶ್ಚನ್ ಸೇಮ್ ಆನ್ಸರ್ ಇದೆ, ಹೇಳಿರೋದು ಕೇಳಿರೋದು ಬೇರೆ ತರ ಇದೆ. First I will explain the diagram, then I will go back to the previous slide. See, in this diagram I have taken the energy level. This is ground state. Normally atoms will be in the ground state. When you incident one photon, atom will go up obviously. This is called spontaneous absorption. For this absorption, nobody's influence is required. And then once it goes to higher level, after spending a brief interval of time, about 10 power minus 8 seconds, atom will come down and will emit the light. The photon is emitted. This is a normal procedure in all emitting sources. Light is obtained by means of this process only. Atoms will go there, will come back and emit the radiation of different frequencies. It depends on the energy levels. For example, you know, in hydrogen atom we get Lyman series, Balmer series, Paschen, bracket, Fund, etc. These are all like this only. So it goes there, spend time, will come down. Within 10 power minus 8 also it can come down, maximum 10 power minus 8 second. And for coming down, nobody's influence required. That is called spontaneous emission. Now comes the third one, which is more important for lasing action. When the atom was in the ground state, if you send a photon, it will disturb the atom, it will influence the atom, it will stimulate the atom. Stimulation means some influence anta. Because of the stimulation, atom will come down, emitting one photon. But how come there are two photons? I am sending one photon, you know. This is not at all absorbed. It is coming out unaffected. So thereby I am getting 2. That means 2 out of 1. Thereby there is increase in the number. Suppose if there are 2 atoms in the excited level, then you get 3 photons. Like that, if you have more and more atoms in the excited state, you get more and more atoms, more and more photons coming out. So these are the 3 possible mechanisms of radiation interacting with the matter. Matter means it may be gaseous matter, solid matter, liquid matter. When light falls on the matter, atoms will go up, comes down. Going up is absorption, coming down is emission. In coming down process, there are 2 emissions. Spontaneously it is happening, spontaneous emission. With force it is happening, stimulated emission. Okay na? So now you know what is spontaneous absorption, spontaneous emission, stimulated emission. So these are the 3 processes. Next, coming back to spontaneous absorption. See, if you have more number of atoms, there will be more absorption. And also, if the incident energy is more, there is more absorption. Therefore, I can say the induced absorption or spontaneous absorption is directly proportional to number of atoms in the ground state. I call it as N1, and the incident energy. Okay, keep it in mind. Next, I will go back to previous slide. More energy you send, more absorption. If there are more atoms in the ground, more absorption. That is first thing. Second, coming to this, if there are more atoms in the excited state, there will be more emission. This emission does not require anybody's support. Therefore, I can say spontaneous emission depends only on the number of atoms in the excited state. If there are N2 atoms, if N2 is more, spontaneous emission is more. Now coming to this, as usual, if more atoms are here, there will be more emission, plus if you send more energy, more emission. So ಅಂದರೆ absorption depends on the energy, stimulated emission depends on the energy, and all the three depend on the corresponding numbers. Absorption depends on ground state number, emission depends on excited state numbers. Is that clear? Now with this explanation I go back to previous slide. See, consider two energy levels E1 and E2, which I already showed in the previous slide. E2 is greater than E1, so E1 is ground state. N1 is the number of atoms. You are all supposed to write the statements like this directly. Please do not start with the derivation. E1 is the ground state, E2 is the excited state, N1 and N2 are the numbers. Okay, and U gamma or U nu is the incident energy. Right. Now comes the first process, induced absorption. What is induced absorption? I told you first one. This is induced absorption, right? Atoms in E1, that is ground state, can absorb the incident energy and go to excited state. The rate of absorption directly proportional to number of atoms. I told you it depends on number of atoms and depends on the energy density. Therefore, I have written rate of absorption is proportional to N1 U nu. I remove proportionality sign, I put equals, then it is B12. Please remember B stands for stimulated or induced. 1 stands for ground state, 2 stands for excited state. 1, 2 means absorption, 2, 1 means emission. I repeat, B stands for stimulated, A stands for spontaneous. 1, 2 means absorption, 2, 1 means emission. Okay, I have first equation with me. Coming to the second one, spontaneous emission. That means this second part, this part. Okay. See, atoms in the excited state will have certain probability to drop to E1 spontaneously. ಅಂದ್ರೆ ಅಲ್ಲಿಂದ ಕೆಳಗಡೆ ಬೀಳೋ probability ಇದೆ, ಬಿದ್ದೆ ಬೀಳ್ತವೆ. Definitely they will fall within 10 power minus 8 second by emitting photon. And the rate of spontaneous emission is depending only on the number, not on the incident energy. It does not depend on the incident energy. Means it does not require anybody's support anta ashtene. Therefore, rate of spontaneous emission is just proportional to N2, that is A21 N2. Okay. Now coming to the last one and most important one, stimulated emission. I told you rate of stimulated emission depends not only on the number, also on the energy. Sorry, ಇಲ್ಲಿ energy miss ಆಗಿದೆ. Here I should have written U gamma, so the U nu, which I have written here. B21 N2 U nu. B means stimulated, 2-1 means emission. A means spontaneous, 2-1 means emission. Okay, now I have stimulated absorption. This I actually called it as the spontaneous absorption. Sorry, it is stimulated absorption, spontaneous emission, stimulated emission. Stimulated andre with energy support ಆದರೆ ಅದನ್ನ stimulated ಅಂತೀವಿ. Without anybody's support ಆದರೆ ಅದನ್ನ spontaneous ಅಂತ ಕರೀತೀವಿ. If somebody is forcing you to do, then you are stimulated. If there is no force, on your own you are doing, that is spontaneous. ನಮ್ಮ ಡೇ ಟು ಡೇ ಲೈಫ್ ಅಲ್ಲಿ ಈ ವರ್ಡ್ಸ್ ಅನ್ನು ಯೂಸ್ ಮಾಡ್ತೀವಿ. Spontaneous, induced, stimulated, etc. Okay, after explaining the three processes, the same are presented in this diagram. Stimulated absorption, spontaneous emission, and then stimulated emission. Under thermal equilibrium, rate of induced absorption is equal to rate of spontaneous emission plus rate of stimulated emission. Now the derivation start. So I will substitute the equation for induced absorption. Okay, this induced absorption is B12 U nu into N1, that is equal to spontaneous A21N2 plus B21 U nu N2. Okay, now take U nu one side, B12 U nu N1 minus B21 U nu N2 is equal to A21 N2, right? Now you take U nu common factor, then B12 N1 minus B21 N2, that is equal to A21 N2. Better you take N2 also common factor, then it is B12 N1 by N2 minus B21, that is equal to A21 N2, right? Now you cancel N2 on both the sides, then U nu is equal to A21 numerator divided by B12 N1 by N2 minus B21. This is the denominator, which I write as A21 divided by B12. I take common factor, then this becomes, sorry, I take B21 common factor, then this becomes B12 by B21 into N1 by N2 minus 1. That means this I have taken as common factor. Okay, actually we have an equation called Boltzmann's equation, Boltzmann formula. ಏನು ಹೇಳುತ್ತೆ Boltzmann's equation? N1 by N2 is equal to e to the power of h nu by kt. This is the Boltzmann's formula. So substitute, I get U nu is equal to A21 divided by B21 into B12 divided by B21. In the place of N1 by N2 I write h nu by kt, right, minus 1, or I simply write U nu is equal to A21 by B21 separately into 1 divided by B12 divided by B21 e to the power of h nu by kt minus 1. Okay, so this is one equation. I call this as equation 1. But according to Planck, I write here, according to Planck, we have equation U gamma is equal to 1 divided by e to the power of h nu by kt minus 1 into 8 pi h nu by c cube. Okay, so this one, because idana first baridi, okay, I will write in that form only. First I will write 8 pi, right, sorry, idana first barbeda bidi, 8 pi h nu by c cube I will bariti first, sorry, 8 pi h nu cube, h nu by c cube into 1 divided h nu cube by c cube by divided into 1 by b1, sorry, b alla, sorry, e to the power of h nu by kt minus 1. Idu Planck's formula. Call this as equation 2. Now if you compare equation 1 and 2, what we can say, A21 by B21 is equal to 8 pi h nu cube by c cube. ಗೊತ್ತಾಯ್ತಾ? ಕಂಪೇರ್ ಮಾಡಿ. ಸೊ ಈ ಪೋರ್ಷನ್ ಇರೋ ಜಾಗದಲ್ಲಿ I have this 8 pi h nu cube by c cube, and in the place of B12 by B21 what I have, see here, what I have, look at this question mark, I have 1, that means B12 is equal to B21. So that means according to Einstein's theory, B12, that is stimulated absorption, is equal to B21, that is for stimulated emission. That means rate of stimulated absorption is equal to rate of stimulated emission. This is the conclusion, and at the same time you can say this is the expression for energy density. This is the expression for energy density. So conclusion, rate of absorption is equal to rate of emission. Whatever is absorbed, same is emitted. Otherwise, whatever is emitted, same is absorbed. This clearly shows that you cannot produce laser just by having 2 levels. It is better to have 3 levels. It is better to have 3 levels. See, 2 level laser is not possible. I show you. If you have a level like this and level like this, atoms are sitting over here, send the light, it goes there and comes back. By the time you take the second one, again it will come back, and there is no amplification of light. Instead of that, if you have one more level, okay, let us say there are many atoms here, take it here, that will come and sit here. Meanwhile, you take another one, it will come and sit here. Meanwhile, you take another one, it will come and sit here. And after some time, the number keeps on increasing. From this level, there will be stimulated emission. And this level is having a life of about 10 power minus 3 to 10 power minus 6 second. This level has got the life of 10 power minus 8 second. This level, of course, infinity. This level is called ground level. This is excited level, and of course this is metastable level. And for lasing action, metastable level is important and very necessary. So Einstein's theory gives us one important information. What? For lasing action, you should have metastable state ಅನ್ನೋದನ್ನ ಅದು ಹೇಳುತ್ತೆ. That is one of the main requirements for the lasing action. ಲೇಸರ್ ಆಗಬೇಕು ಅಂದ್ರೆ ಮೆಟಾಸ್ಟೇಬಲ್ ಸ್ಟೇಟ್ ಇರಲೇಬೇಕು, ಗೊತ್ತಾಯ್ತಲ್ವಾ? ಸೊ ಲೇಸರ್ ಆಗ್ಲಿಕ್ಕೆ ಬರೀ ಮೆಟಾಸ್ಟೇಬಲ್ ಸ್ಟೇಟ್ ಅಷ್ಟೇ ಅಲ್ಲ, ಬೇರೆ ಬೇರೆ ಕಂಡೀಷನ್ಸ್ ಇದೆ. ಒನ್ ಆಫ್ ದ ಮೇನ್ ರಿಕ್ವೈರ್ಮೆಂಟ್, ಒನ್ ಆಫ್ ದ ಮೇನ್ ಕಂಡೀಷನ್ಸ್ ರಿಕ್ವೈರ್ಮೆಂಟ್ ಅಲ್ಲ, ಒನ್ ಆಫ್ ದ ಮೇನ್ ಕಂಡೀಷನ್ ಈಸ್ presence of metastable state. Now look at the question, next question, that is number 3. Discuss the conditions for laser. ನಾನು ಆಗಲೇ ಹೇಳಿದ್ನಲ್ಲ, ಲೇಸರ್ ಆಗಲಿಕ್ಕೆ, ಲೇಸರ್ ಬರಲಿಕ್ಕೆ we need some conditions to be satisfied. What are those conditions? Number 1, population inversion. This is main thing. What is population inversion? See, we have energy levels like this. We normally have more atoms in the ground state. Let me take it as N1, and very few in the excited state, N2. N1 is greater than N2. This is normal situation. This is not of use. Actually, I want more number of atoms in the excited state. I want more here, okay, less here, okay. That means the atoms should be sent to the higher level. So I need more atoms in the excited state. N2 should be greater than N1. This is actually an abnormal state, and that abnormal only I want. So I want more population in the excited state, and that situation is known as population inversion. So the sentence goes like this. Population inversion and definition ana helidini nodi. When the material is in thermal equilibrium, population of the excited level is far less than the ground level. That means N2 less than N1, or N1 is greater than N2. This is not suitable for producing the laser, because I want more atoms in the excited state. When more atoms come down to the ground state at a time, I get more number of photons. Therefore, we need N2 greater than N1. This abnormal situation is known as population inversion. So I want population inversion. Now, metastable state. This one just few minutes back I explained. Normally, population inversion cannot be achieved in the excited state. I want one particular state, say what is that, metastable state. Inenagute, this level is 10 power minus 8 second. This level is infinite. So in between I want level, because 10 power minus 8 is too short to achieve the population inversion. So if I put atoms here, within 10 power minus 8 they will come down. By chance, if I can have a level where they can sit for quite some time, and if their lifespan is more, then I have breathing time, so that I can take few more atoms from the ground level to higher level. See, excited level 10 power minus 8. 10 power minus 8 very small, very short to achieve the population inversion. Therefore, I need a metastable state where I can achieve the population inversion. So that is another important condition for lasing action. Without metastable state, it is impossible to achieve the population inversion. And without population inversion, you cannot have lasing action. So the sentence goes like this. In order to achieve the population inversion, the excited atom need to wait in the excited state for some time and for some more atoms to come. It is possible only if the lifespan of the excited level is more than usual, more than 10 power minus 8 second. 10 power minus 8 ತುಂಬಾ ಕಡಿಮೆ, ಅಲ್ಲಿ ಕಾಯಕ್ ಆಗೋದೇ ಇಲ್ಲ, ಇನ್ನೂ ಒಂದಷ್ಟು ಆಟಮ್ಸ್ ಬರುತ್ತೆ ಅಂತ ಕಾಯಕ್ ಆಗೋದೇ ಇಲ್ಲ. 10 power minus 8 ಸೆಕೆಂಡ್ ಅಲ್ಲೇನೆ ಆ ಲೆವೆಲ್ ಅದನ್ನು ವಾಪಸ್ ಕಳಿಸ್ಬಿಡುತ್ತೆ. Therefore we cannot have more atoms in the excited state. That's why I want one level where atoms can stay leisurely. ಸ್ವಲ್ಪ ಹೊತ್ತು ಕಾಯೋದರ, ಈಗ ನಿಮ್ಮ ಕಾಲೇಜಲ್ಲಿ ರೆಸ್ಟ್ ರೂಮ್ ಅಥವಾ ಸ್ಟೂಡೆಂಟ್ಸ್ ಲಾಂಜ್ ಅಂತ ಇರುತ್ತಲ್ವ, ಆ ತರ ಅಲ್ಲಿ ಸ್ವಲ್ಪ ಹೊತ್ತು ಆರಾಮಾಗಿ ಕೂತ್ಕೋಬಹುದು. ಹಾಗೆ ಮೆಟಾಸ್ಟೇಬಲ್ ಸ್ಟೇಟ್ ಕೂಡ, ಮೆಟಾಸ್ಟೇಬಲ್ ಸ್ಟೇಟ್ ಅಲ್ಲಿ ಆಟಮ್ಸ್ ಬಂದ್ರೆ ಒಂದು ಸ್ವಲ್ಪ ಹೊತ್ತು ಕೂತ್ಕೋತವೆ, ಹಾಗಾಗಿ ಇನ್ನೂ ಒಂದಷ್ಟು ಆಟಮ್ಸ್ ಬಂದು ಅವುಗಳ ಜೊತೆಗೆ ಕಂಪನಿ ಕೊಡ್ತವೆ. Thereby the number keeps on increasing. Such type of excited state is known as metastable state. Okay, I have metastable state, I have atoms in the ground state. Oh, I have to achieve population. How to achieve population inversion? Just by sending the atoms from ground state to higher state. Normally atoms ಎಲ್ಲ ground state ಅಲ್ಲೇ ಇರ್ತವೆ. We have to send them to the higher state. How do you send them? Only by means of pumping process. This is the next condition for lasing action. So how do you achieve population inversion? By means of sending. ಈಗ ground ಇಂದ excited ಕಳಿಸಬೇಕು, excited ಇಂದ metastable ಬರ್ತವೆ. So in order to kick them, you have to supply the energy. So by supplying the energy, we can take them to higher level. This process is known as pumping process. So next condition, pumping process. For pumping process, you can use electrical energy or optical energy or chemical energy, but not thermal energy. Thermal pumping is not possible. Okay, by sending an intense flash, we can kick the atoms to higher level. By applying high voltage, we can kick atoms to higher level, or by some chemical processes, we can make the atoms to be in the excited state. This process is called pumping process. So three important conditions are population inversion, metastable state, pumping process. Conditions ಇದು ಇರಲೇಬೇಕು. ಇದನ್ನು ಅಚೀವ್ ಮಾಡಿ ಮುಂದಕ್ಕೆ ವಾಟ್ ಎವರ್ ವಿ ಡೂ, ದಟ್ ಈಸ್ ರಿಕ್ವೈರ್ಮೆಂಟ್. ಸೊ ದಟ್ ಐ ವಿಲ್ ಟೇಕ್ ಅಪ್ ಇನ್ ಮೈ ನೆಕ್ಸ್ಟ್ ವಿಡಿಯೋ. ಸೊ ಐ ಹ್ಯಾವ್ ಡಿಸ್ಕಸ್ಡ್ 3 questions. Please watch my videos carefully and regularly. I will come back to you with few more videos. Okay, thank you very much. And notes available in the description box. I have given the link, please copy. And also modern physics and lasers numerical videos are also available. I have made numericals videos on numericals already in 2020 itself, and those videos are available. The link is given in the description box. Just watch those videos also, so that you can upgrade your knowledge and you can face your exams comfortably. Thank you very much.